Hello there. I told you that I wouldn't be in class today, so I have a video of the lesson. So we're on Unit 3, Lesson 7 in your textbook. It's on pages 44 through 50, and it's titled Inequivalent Equations. So what we're going to be working on today is we're going to be working on solving x squared equations and the square root of x equations. Um, to do that, sometimes we make things called inequivalent equations. And so just kind of keep that in the back of your mind as we're working today. One thing to note is that because this is a video and not a live lesson, you can pause the video at any time to catch up on notes. I'm probably not going to write down as much as I would if we were in class. Simply because I don't want to make the longest math video in the history of the United States. This is a pretty long lesson, page-wise, so I will try and have clear explanations that don't take too long. So to begin with, we have this warm-up. What do you notice and what do you wonder? So we talked about x squared equations and square root equations. We talked about those the other day. And so when I look at these, it kind of brings back some memories about what we learned about x squared equations, or equations like x squared equals 4. So let's remember this equation comes from a parabola, and so it has two solutions, positive 2 and negative 2. And those happen to be the same solutions as this equation, because you can see, oh, this factor would give me a solution of x equals 2, and this one would give me a solution of x equals negative 2. So I notice that these two equations have the same solutions. I also know that this one has no solution, because x squared would be a positive value, and a positive value is not going to equal a negative value. And then finally, the last one, I noticed that it only has one solution because this implies the positive root of 4. So this has one solution of x equals 2. Okay, so we're going to be using those ideas that we learned in class on Tuesday and apply them to equations that are just a little bit more complex, just a little bit. Okay, so let's move along here. And this title of this activity is actually a great warning. Careful when you take the square root, okay? So just keeping in mind that when we have x squared in the equation, the original equation, there's, we have to just be careful and think about how many solutions there could be when we get to our final answer. So this story is about Tyler. Shocking, it's not about Claire this time. Tyler was solving this equation, x squared minus 1 equals 3. And he says, I can add 1 to each side of the equation, and it doesn't change the equation. I get x squared equals 4. And so you can see, oh yeah, if you were, following the rules of how you can add the same number to both sides, it cancels out those ones, and we do have x squared equals 4. So he's saying, it doesn't change the equation. This is his statement. It doesn't change the equation. So then, I believe this name is Priya. So Priya, another person that's not Claire. We've had so many stories about Claire. But this time Priya said, it does change the equation. It just doesn't change the solutions. Well, that's an interesting thing to think about. It changes the equation, but it doesn't change the solutions. So she made these two graphs to kind of show him what she was talking about, all right? So it looks like this first graph is y equals x squared minus 1. And then this one is y equals x squared. And notice, get some colors here. It says, how can you see the solution to x squared minus 1 equals 3? So for x squared minus 1 equals 3, that line at 3 has been highlighted. See that? And so x squared minus 1 equals 3 has two solutions where they intersect. The y equals 3 line and the y equals x squared minus 1 parabola. So one solution is x equals negative 2, and the other one is x equals positive 2. And as I'm sure you've jumped ahead and realized, the solution in the second graph allows us to see x squared equals 4. So here's, the line y equals 4, and it intersects y equals x squared in two places, where x is equal to negative 2 and where x is equal to positive 2. Okay, so we do get the same solutions for x, but they're not the same points, right? Because we can clearly see, oh, this is negative 2, 3, and positive 2, 3. And then this is negative 2, 4, and positive 2, 4. Okay, so you might think about then, that kind of shows us why the equations have the same solutions. So this function goes through negative 2, 3, and 2, 3. And this one goes through negative 2, 4, and 2, 4. So it's 2 that makes the first, and negative 2 that makes the first equation equal to 3. And it's also 2 and negative 2 that makes the second equation equal to 4. So you can see on the graph that they do have the same solutions. Okay, so then Tyler is going on in trying to solve it algebraically rather than graphically, which is great. So remember, the first thing he did is he started with x squared minus 1 equals 3. He added 1 to both sides of the equation, and now we're at x squared equals 4. And so Tyler says, oh, then I'm going to square root both sides, and I get x equals 2. Tyler's saying that's the solution. And then Priya says, but the graphs show there are two solutions. So what went wrong? What went wrong is at this step, he needs to address the positive and negative square root of 4. Okay, so when you have an equation that has x squared and you eventually isolate that and then square root, you need to remember to put the positive and negative symbol in front of that square root. So he didn't do that there. His final answer should be positive and negative 2. Okay, in the next activity, we're going to be thinking kind of big picture on how we can relate something like this type of thinking into a new problem. Oh, look at that. It's x plus 3 in parentheses squared. Well, that's different. We haven't seen those yet, equal to 4. Okay, so let's look at this one. So Han, we're just getting all sorts of new people in our story today. Han was solving this equation. So x plus 3 divided by 2 is equal to 4. He said, I know that half of x plus 3 is 4, right? Because it's being divided by 2 and it's equal to 4. And then he says, so x plus 3 has to be 8. So he didn't really do traditional algorithms to figure that out. He just was like, oh, I know 8 divided by 2 is equal to 4. So x plus 3 then has to equal 8. Okay? And he's totally correct. So we want to think about how can we apply that kind of thinking, like rather than like an algorithm, to solve this equation. So if I know that something squared is equal to 4, we all know that 2 squared is equal to 4, right? So we could say, oh, since 2 squared is equal to 4, then x plus 3 must equal 2, right? So if this squared is equal to 4 and 2 squared is equal to 4, then x plus 3 from there must equal 2. And so you can take like a quick step, kind of a shortcut, not really, to get to your solution. We're going to subtract the 3. We're going to subtract the 3. We get x equals -1. And then we think to ourselves, I must have done something wrong. Why must I have done something wrong? Well, this is a parabola, and I only came up with one solution. So what other number can you square and get an answer of +4? 2 squared is equal to 4, but what else is equal to 4? Oh, -2 times -2 is also equal to +4. So that's our advice. We're going to give this advice to someone who is going to solve an equation like that, is to remember not only is 2 squared equal to 4, but I'm going to write and in caps, -2. Notice I put parentheses around that because this is proper notation. If you didn't have parentheses, the actual answer here would not be 4. It would be -4. Okay, so these are both, when we square those values, multiply them by themselves, we get an answer of 4. So we have actually 2 solutions up here. It's not just positive and -1 though. You have to solve them separately. So from this step here, since -2 squared is also equal to 4, then I would say, oh, and also x plus 3 equals -2. And then from there, continue to solve. We get x equals -5. Okay, so this equation actually also has 2 solutions, x equals -1 and x equals -5. And because this is kind of a new concept, we're going to go ahead and just check those real quick. So the original equation, x plus 3 squared equals 5. So -1 plus 3, sorry, equals 4. I said 5, I meant 4. -1 plus 3 squared. Does that equal 4? -1 plus 3 is 2, and 2 squared is 4. So that means this solution checks. And then we'll try the other one. X equals -5. -5 plus 3 squared. Does that equal 4? -5 plus 3 is equal to -2. -2 squared is equal to 4. So that checks. Now, you might be at home looking at your answers on a calculator and you're like, Miss Moret, you're wrong. Miss Moret, you're wrong. -2 squared does not equal 4. -2 squared equals -4. And I'm going to say, really? Because if you use parentheses like you're supposed to when you square a negative number, you get a positive answer. If you don't use parentheses, you did it wrong. No other way to say it. So make sure when you raise a negative number to a power, you tuck it, the number inside of parentheses, the exponent on the outside, and then you will be correct. It's positive 4. Okay. All right, we're making great progress, you guys. Let's see here. We have a new equation over here. Something new. What happens when you square each side? So we know like square and square root, they are inverse operations. They just don't always work like adding and subtracting, totally inverse operations. You don't have to worry about that operation messing up with your final solution. Same with multiplication and division. But like square and square root, there's a little more to it. So let's go ahead and go through. This is 7, 3. Okay, so another new person in our story. Excellent. So my was solving this equation. The square root of x minus 1 is equal to 3. Now, you guys, at the end of the lesson, there's some really good directions in the summary about strategies for solving. So I'm going to use the strategies and then save, like, I'm not going to have you write out steps because it's in the lesson summary. So we'll get to that, okay? All right. So she said, or he, I don't know, doesn't matter. It does say she. She said, I can square each side of the equation to get another equation with the same solution. Well, that kind of makes sense, right? So if we started with the square root of x minus 1 equals 3, then we could square both sides. So because square root and square are inverse operations of each other, when you square this, you get what was under the radical, x minus 1. And then 3 squared is 9. And then finally, by adding 1 to both sides of the equation, you get x equals 10. We're going to check to see if her solution makes the original equation true. That's really important that when we check solutions, you always want to go back to the very original equation. So the OG, right? Right there. Okay, so if x equals 10, we're looking at, I'll put it over here. Does the square root of 10 minus 1 equal 3? Well, 10 minus 1 is 9. So this is the square root of 9. And the square root of 9 is 3. So yep, it worked. So then looking at the next example, this is Andre. Andre says, I tried your technique to solve this, but it didn't work. Why doesn't it work? Well, let's look at what Andre's trying to solve. He's trying to make a positive value equal to a negative value. So if he just took her advice and squared both sides of the equation, it gets a little bit tricky because it kind of looks like it's going to work out. Okay, so let's investigate, see what's going on here. I think Andre has figured out something. So when you square the square root of x minus 1, you get x minus 1. And negative 3 times negative 3 is positive 9. So again, it totally looks like, oh yeah, I'm going to add the 1. Bam, bam. We get x equals 10. Same solution. We're geniuses. Except that, how can you make a positive number equal a negative number? I mean, really and truly, you just can't. And we can show that by doing a check. This is why checks become so important. So the check goes in the original equation. Does the square root of 10 minus 1 equal negative 3? Does it? Well, again, 10 minus 1 is 9, so this is the square root of 9, which is 3. And 3 does not equal negative 3, so this does not work. In fact, this equation actually has no solution. Okay. All right. This is the longest video ever, but we have one more section to get through. So what I would suggest for you guys here is I would suggest that you pause the video right now and give these 4 equations a shot. It says find the solution to each of these equations or explain why there is no solution. Okay, so I would recommend pausing the video, like I said, and then work them out and see, kind of check your understanding by going back and playing and then seeing my work and how it works out. Okay, so hopefully you did pause the video and now you're back to check your answers. Here we go. So the strategy to solve equations like this is to first isolate the square root portion of the equation. So this is already isolated. This one here, we're just going to divide by a negative 1. This one here, we're going to have to add the 4 first, and this one here, subtract the 9 first. So isolate the square root portion, then square both sides of the equation, and then solve as needed. Okay? So this is already isolated. I'm going to go ahead and square both sides of the equation. So I get t plus 4 equals 9. Subtract the 4. T equals 5. Okay, I think that's going to be a good solution, but I better check to make sure. I'm going to plug the 4 in, the 5. So we have the square root of 5 plus 4. Does that equal 3? The square root of 5 plus 4. 5 plus 4 is 9, so this is the square root of 9, which is 3. So that's a good answer. T equals 5. Number 2. I'm going to isolate the square root by dividing both sides by negative 1. So I get 10 equals the square root of a. At this point, I can square both sides of the equation because the square root is isolated. Okay, 10 squared is 100. And then the square root of a squared is simply a. So I think this is the answer. A is equal to 100. So I'm going to plug it in. Is this a true statement? Well, the square root of 100 is 10. So the negative square root of 100 is negative 10. So I have negative 10 equals negative 10. That checks. So number 2, a is equal to 100. Okay, on number 3, I'm going to isolate the square root part of the equation by adding the 4 to both sides. And so we get the square root of 3 minus is equal to 4. So the square root is isolated. I'm going to square both sides of the equation. And squaring the left side just removes the radical. So we have 3 minus w. 3 minus w equals 16. 4 squared is 16. Okay, so I'm running out of space. I'm going to just move this up here. 3 minus w equals 16. Okay, subtract the 3 from both sides of the equation. 16 minus 3 is 13. Don't forget, though, there's a minus. So negative w equals 13. So divide by negative 1, and we get w equals negative 13. Maybe. Okay, so now we're going to check. If I put negative 13 here, does this work out? So I want to completely use the original equation. Don't make any changes to it. Minus 4, does that equal 0? Minus 4 equals question mark 0. Okay? 3 minus negative 13, well, that is 16. So this is the square root of 16 minus 4. The square root of 16 is 4, and 4 minus 4, in fact, does equal 0. So once again, it checks. Okay? So then we get to the very last one. And we have the square root of z plus 9 equals 0. I need to isolate the square root part of the equation by subtracting the 9. So we get the square root of z equals negative 9. And right here, guys, right here at this point in time, I'm going to say no solution. This is a positive number. This is a negative number. I mean, if you want to continue to work on it, I'm not going to stop you. You would get z equals 81. That looks fine, right? But then when you go to plug it in, the square root of 81 plus 9, does that equal 0? No, it doesn't. The square root of 81 is 9. 9 plus 9 is 18. 18 does not equal 0. So this does not check, and this one is a no solution. Okay, all right. I'm going to zoom out for a minute. So if you wanted to see like all of my work one more time, there it is. I'll even refocus because on my screen it looks a little blurry, so not sure what you're seeing. Okay, guys, that's the end of the lesson. The only thing left to do is the lesson summary. I hope you guys are starting to have a true appreciation for, honestly, this textbook gives the best lesson summaries of any textbook I've ever used. So I am like, raise the roof for illustrative math because they did that very well. So let's talk about this. Every positive number has 2 square roots. It has a positive one and a negative one, right? Every positive number has a positive root and a negative root. They do exist. You just need to know which one's being asked for based on whether it says square root or negative square root, okay? You can see this by looking at the graph of y equals x squared. So 4 has a positive root of 2 and a negative root of negative 2. That's what this is saying. Down below, if y is a positive number like 4, then we can see that at y equals 4, y equals 4 crosses the graph in 2 places. I just circled them. I'm going to draw that line in there. That's what it's talking about. This is the line y equals 4 crosses y equals x squared in 2 places. 2 solutions, the positive square root of 4 and the negative square root of 4. So positive and negative 2. So for any positive number a, y equals a will cross the graph in 2 places, and x squared equals a will have 2 solutions, the positive square root of a and the negative square root of a. That is a super important this whole row that whole row of words along with that. Super important right there to understand. Okay. Now the next section is not about x squared equations. It's about square root equations. Those are different. So let's look at that example. When we have a square root equation like the square root of t minus 6 equals 0, we can isolate the square root and then square each side. Okay, so we isolated the square root. I need some more highlighter colors. How about green? I haven't used green tonight. I'm saying tonight because it's currently 9 p.m. on Tuesday night when I'm making this video. Just a little fun fact for you. Okay. So when we have a square root equation like this, we can isolate the square root and then square each side. So that's the strategy I told you didn't have to take notes on because it was going to be in the lesson summary. And there it is, right there. Okay, so we look at this example, and I'm just going to off to the side state what happened from each step to the next. So to get from here to here was adding 6 to both sides. To get from here to here, we square both sides of the equation, and then obviously this will be the solution. You always want to check, though, to make sure, because sometimes when you follow this process, it looks like you have a solution, but doesn't actually work. That's going to happen on the next page, which is the end of the lesson summary. Okay, so this looks kind of like the last equation that we did in those 4 little practice problems. So sometimes squaring each side of an equation gives results that aren't solutions to the original equation. So for example, when you subtract 6 from both sides to get to the next step, you should notice right here that the equation actually has no solution. But then when you square both sides, it ends up looking like t is equal to 36. Well, if we were to plug that back into the original equation, the square root of 36 plus 6 becomes 6 plus 6, which is 12, not 0. So although it looks like 36 could be the solution, it doesn't work when you plug it back in. And it's because of the fact that right here, we're trying to say that there's a case where a positive number is equal to a negative number, and that's just not going to happen. Not going to happen. Okay, so then there's a little reminder there at the bottom to remember, sometimes remember that. Sometimes the new equation has solutions that the old equation doesn't have. Always check your solutions in the original equation. So when your middle school teachers first started making you check your solution, it was just to see if you did the math right. But now that you're checking your solutions, is to make sure that they're actually solutions. Not that you didn't do the math right. This is pretty simple math we're doing today, but it's not always going to give you the right solution. So all right, kids, that is the end of my video. I think it's a world record. I'm going to apply for a trophy. Have a great weekend, and I will see you on Tuesday. Stay tuned, though, because I'm also going to make the homework video in a moment, so you'll see me again.